lesson 2.5, part 1, solving rational equations. The learning target for this lesson is that you can solve rational equations. This is something that you did in Algebra 2. So it is a review of a skill from Algebra 2. A rational function. First, we're going to the definition of a rational equation. A rational equation, or expression, is nothing more than a fraction in which the numerator and the denominator are polynomials. So, a rational function is a function where the numerator or denominator, usually both, are polynomial functions. I'll call it p of x and q of x. Sometimes they're called a of x and b of x, where p of x and q of x are polynomials. Solving rational equations. The steps to solving a rational equation is to first find the least common denominator of all terms. Then we multiply by the least common denominator and see what cancels to simplify. And then we solve the remaining polynomial function. Usually a polynomial function, but it would no longer be rational. In multiplying by least common denominator, we may introduce extraneous solutions. So your very last step is to check for extraneous solutions. I'll go through these 4 steps on these next several problems. In our first example, we have 20 over x plus 3 minus 4 equals 0. The denominators on the 4 and 0 are 1. The least common denominator of those 3 denominators is x plus 3, or 1 times x plus 3. So we're going to multiply every term, and do step number 2, multiply every term by x plus 3. Here, I have x plus 3 over 1 divided by x plus 3. The factors cancel, because it's the same factor in the numerator and in the denominator. So that leaves me with 20. Here, I have minus 4 times x plus 3. And on the other side, I have 0 times x plus 3, which is just 0. I'm now going to simplify, so I'll distribute the negative 4. So I have 20 minus 4x minus 12 equals 0. And I'm going to combine like terms. So negative 4x plus 8 equals 0. I'm going to subtract 8 from both sides. Negative 4x equals the opposite of 8. Divide by the opposite of 4, x equals 2. Well, we're pretty sure it equals 2. We need to plug it back into check. I can do that myself, compute it myself. 2 plus 3 is 5. 20 divided by 5 is 4. Minus 4 is 0. So it works. You can also do what we did in the last one, where we have the left side, we put it in for y sub 1, the right side in for y sub 2, and then plug in 2 into the table. We should get 0 for both. Letter B. These are already factored. I'm going to zoom in on it so you can see it a little better. These are already in factored form, except for the x squared minus 8x, or minus 6x plus 8, which does factor to x minus 4 by x minus 2. The least common denominator is going to, I have a pair of x minus 2, so I'll need one of the x minus 2 and a pair of x minus 4s. So for my least common denominator for this, I have x minus 4 by x minus 2. When I multiply by this, all of these denominators should disappear. If they don't, then I have did not find the least common denominator. So I'm going to multiply this one by x minus 4 by x minus 2, and this one by x minus 4 by x minus 2, every single term. Here, both the factor of the x minus 4 and the factor of the x minus 2 cancel, leaving me just the numerator of 4. Here, the factor of x minus 2 cancels, leaving me 3x times x minus 4. Here, the factor of x minus 4 cancels, leaving me 2 by x minus 2. I'll now simplify by distributing the 3x and the 2. I end up with a quadratic. I have to combine like terms. I'm going to combine like terms, and I'm going to subtract this 4 to get it equal to 0. So I have 3x squared minus 10x minus 8, which might be factorable. Let me check the discriminant. 100 minus 4 times 3 times negative 8 is 196, which is a perfect square of 14, so it is factorable. I'm going to factor it, but you could have just completed that with quadratic formula at this point if you want. 3 times 4 is 12, minus 2 is 10, but I need it to be negative 10, so positive 2x, negative 12 will give me negative 10 in the middle. Those are my factors for this quadratic. So the answers, as I set each of these equal to 0, are x equals negative 2/3, or x equals 4, or both, or neither. I'm not sure. So I'm going to check. I'm going to show you how to plug it in the calculator. You have to make sure that your numerator and denominator, if your numerator has multiple terms, it needs to be in parentheses. This one doesn't. The denominator does, so that has to be in parentheses. So 4 over x squared minus 6x plus 8. That's the left side of the equation. On the right side, we have 3x over, there's only one term, so I don't need parentheses. But in the denominator, I do, x minus 2, plus 2, only one term, so I don't need parentheses. But in the denominator, there's more than one term, so I do. And I go to my table, and I plug in negative 2/3, which turned out to be balanced, so that is a solution. And 4, which, while they both give me an error, well, gee, I wonder why they both give me an error. It's a domain restriction, right? X can't be 4, it would make this denominator 0. So this one is extraneous, an extraneous solution. X equals negative 2/3 is our only solution to this rational equation. We'll look at 2 more examples in these video notes where we continue to follow the steps of finding the least common denominator, multiplying every term and simplifying, and then solving the remaining function and checking for extraneous solutions. In this next problem, the least common denominator of 1 and x minus 8 and 1, we have to look at the entire equation, is x minus 8. So I'm going to multiply every term by x minus 8, except I'm not going to distribute it yet, because here, that factor cancels with the factor in the denominator. Here, when I distribute the x through x minus 8, I have x squared minus 8x. Here, when I multiply by 0, I get 0. Solving the remaining equation by factoring, I have x by x minus 8 equals 0, which means that either x equals 0, or x equals 8, or neither. Well, if I plug 0 in, I don't know. I don't think that's going to work. We're going to test it. And if I plug 8 in, we have a problem because it's going to make the denominator a 0. But let's look. So on the left side, I have x plus 6 over, in parentheses, because there's more than one term, x minus 8. On the right side, I have 0. I don't want to see it graphed. I want to see the table. So when I hit 0, it is not balanced. Negative 0.75 and 0 are not equal, which that would have been 6 over negative 8, negative 3/4. When I plug in 8, just as expected, we get an error on this side. So for this one, both solutions are extraneous, meaning that there is no solution for this problem. Very important check for our extraneous solutions. lesson from 2.1 where you were squaring things, and here where we're multiplying by the least common denominator. It changes the equation, so we have to be careful. Alright, so now we have this one. I'm going to first factor this. X minus 6 by x plus 3, let's double check that, negative 6 and positive, yes, those are the correct factors. Of these terms, the least common denominator, I don't want to multiply them all together, I have two that are in common, so I have one factor of that, and these two are in common, so I have one factor of that, and so there's my least common denominator. I'm going to multiply that least common denominator times, by the way, I'm eliminating this for now because that is this underneath. We multiply all of these by x minus 6 by x plus 3, by x minus 6 by x plus 3, by the quantity of x minus 6 and x plus 3. On the leftmost term, the factor of x plus 3's divide away, leaving us with 2x by x minus 6. On the second term, the factor of x minus 6 cancels, leaving us with positive 3 times x plus 3. On the right-hand side of the equal sign, both the factors of the x minus 6 and the factor of the x plus 3 cancel, leaving us with just 27. We now distribute, giving us 2x squared minus 12x plus 3x plus 9 equals 27. We're going to combine like terms, giving us 2x squared minus 9x. I'm also going to subtract the 27 to get this quadratic equal to 0, minus 18 equals 0. And I'm pretty sure this is factorable, but I'm going to use the discriminant to check. 81 minus 4 times 2 times negative 18 is 225, which is a perfect square. So that does work. I can either finish with the quadratic formula or factor it now. 2x times x for 18, we get it to add to 9. I'm going to try 6 and 3, yes, 12. I need it to be negative 12 and positive, so there's the negative 12x, there's a positive 3x adding to negative 9. Set each of these factors equal to 0 to continue solving our quadratic. We have x equals negative 3 halves, or x equals 6, or both, or neither. The only way to know is to plug it back in to check. Rather than do that by hand, I'm going to put in the left side. I have one term in my numerator, so I don't have to do the numerator in parentheses. I have 2x over, in parentheses, x plus 3, plus 3 over, in parentheses, x minus 6. On the other side of the equation, I have 27 over, in parentheses, x squared minus 3x minus 18. I'm hoping I have the correct sign on that. And I come and I put in negative 3 halves. So I go to my calculator and plug in negative 3 halves, and I've got that the equation is balanced with negative 3 halves. I expect that 6 will not work. Some of you might have already known 6 will not work because looking at the factors that are in the denominator, x cannot equal negative 3, which we didn't have as a solution anyhow. X cannot equal positive 6 because it will make this an undefined fraction as well as this. So we get an error on both sides because that creates undefined values. This one is extraneous. This is our solution. This concludes the video to review what you learned in Algebra 2 for solving rational functions. Finding the least common denominator of all the terms, multiplying through and canceling out common factors to simplify, solve the remaining function, and checking for extraneous solutions. We'll be doing some practice with this in class. Have a great day.